So hello guys, welcome to Codage VIT. Today's question is correctness of printed sheets. Okay, number labels are to be prepared by a small scale printing company. The sheets are cut into uniform dimension and fed into printing machine. The printing machine has to print some numbers in ascending order. Okay, so these are the numbers 0 to 9. The printing machine does not do the job always correct in print numbers. It prints numbers in wrong order sometimes. But some of the printed sheets are easily correctable by a single cut and a single paste. For example, if the printed sheet has number 17, 19, 23, 34, 56 and 71 and 80, then it has done job correct. If the printed sheet has numbers this 76, 89, 91, 96, 23, 28, 29, 37 and 45, then it is easily correctable since by a single cut after 96, a single paste before 96 will contain number in order, that is cut after the fourth number in the printed sheet will do. If the printed sheet has number 76, 89, 91 and so on up to 45 like 93, 27, 28, it is non-correctable. Given the numbers in printed sheet, write a C++ code to categorize into correct, easily correct or not easily correctable. So question is we will be given a set of numbers like this, and we have to see that is it easily correctable or not, or it is already correct. Already correct is the condition when this array is sorted like in ascending order. As you can see here 17, 19, 23, 34, 56, 71 and 80 all are in the ascending order, hence it is correct answer. So if the given array is sorted already, we need to directly print correct. Now you can see here like up to 96 all the numbers are sorted. Okay, like 76 is smaller than 89 and so on, but after 96 23 is not smaller than 96, so we need to cut after 96 like this cut 96 after we have to do cut and paste this whole 23 to 45 before 76, so it becomes a sorted array. Okay, so let's see how we will do this. So first of all, what we can do is we can iterate over this set and we can find what is the index up to which the array is sorted, like up to what is the index of the number up to which the thing is correct, like the array is correct. Okay, so for here 76, 89, 91 and 96, we can see here up to 96 the array is correct, but after 96 the array is not correct. So what we have to do is we have to cut after 96. So we will first of all find the index where up to which the array is sorted, and we have to find that index and we have to separate these two array like 23 up to 45 and 96 76 up to 96. Okay, so we have to separate this array and then we have to combine this array in such a way that it is sorted. So first of all, let's see what will be the code. So first of all, let's take it input. So n is okay. So I didn't explain the input format. First line contains the count of numbers printed in the sheet, like this number. Next line contains the numbers printed on the sheet separated by a space. Okay, so first of all, let's take the input. Then second is taking a list. Now we will first of all check that the given list is sorted or not. If it is sorted, we will directly print as it is correct. Okay. Now what we will do, we will take a C as a pointer, like pointer means a variable which will tell us the count. Wait, I will explain through the code what we are doing. And A as another pointer. So I will explain why we are doing this. Now we will iterate over the loop from index 0 to length -1. Now we will see if 96 is greater than 89 or not. If yes, we will move the count to 1. Okay. So what we are doing, if this is there, we will increment this C. This is C is the basically the count we are keeping. So okay, and A our goes from A equals to plus equals to I plus 1. Okay. So next what we will do, so I will tell you why I did this. So first of all, let try and run this. Like for first index, like 0, L of 0 is 76, then I plus 1, what is that? 89. This both, so L of I is not greater than L of I plus 1, so count will not increase, like C variable will not increase. Then for this index, first index, previous index 89 is not greater than 91, hence count will not increase. 91 is smaller than 96, hence count will not increase. But 96 is greater than 23. Okay, so count will increase. C equals to C plus 1, like this. C equals to C plus 1 is basically means that. Okay. Okay, so this is the count. Now 96 is again greater than 23. Okay, so we have to again increase the count. Like sorry, first it was incremented. Now 23 is smaller than 28. Okay, like 23 is smaller than 28, hence we will not increase, and hence on. You can see here that if the count is 1, that cutting is possible. Okay, cutting is possible. So we will write here, if C equals 1, what we will do here is we will make an array. Okay, array like a list where we are storing this index from here, like from here to end, and then adding this list, like 70 to 96 and 23 to 45. Now for knowing the index, that where we have to break the index, that's why I kept this A equals to 0. So first of all, let's talk about A. A is 0. So first of all, if L of I is greater than L of I plus 1, so L of I is 76 and this is 89. Okay, so this is not working, like this is, it will not go in through if condition. Okay, so it will remain same. Then again, next, for the next, if L of I is greater than L of I plus, not possible. L of I is greater than L of I plus 1, not possible. Here also not possible. Here it is possible. Okay, 96 and 23. So A will go from I. What is I here? 0, 1, 2, 3. So A will go from 0 to 4th index. Okay, so from 4th index we have to start, like from 23 we need to break it up to 45. 23 to 45 one list, and 76 to 96 one list. Okay, so we will make a X list where we will get from, like from A to n minus 1, first this and then this up to A. Okay, so this is the code that I am writing for taking the elements into X. Okay, so here after this our X will look like this. Our X will look like this: 23, 28, 29, 37, 45. Then after 45, 76, 89, 91 and so on. Okay, so now, okay, so our X will look like this, like X will be looking like this: 23 and 96. Okay, so our X will look like this. Now what we have to check here is that if this array is sorted or not. So first of all, we can see here that 23, 28, 29, 37, 45, 76, 91 and 96, these all are in sorted form. Okay, so first of all we have to check if C equals to 0, like this is if the given list was already sorted, okay, so there will be no count increment in C variable. So hence if C equals to 0, we will directly print as correct. Like if it is already sorted, the array input array is already sorted, we will give it as correct. Now what we will do, we will check that if the count is 1, okay, we saw that if count was 1, we are able to correct the list, okay. So if count is 1, like if C equals to 1, and the this working we have done for finding that it is ascending or not, and we will see that after this working the X array is sorted or not, okay. If it is sorted, X equal to sorted, so here I have defined that S equal to sorted L, so this we will use here. Sorted L means that is it sorted or not, okay. So it is, if X equals to S, we need to print as easily correctable. Now we will check another case. If C equals to 1 and X is not sorted, like there may be condition like this here. You can see here 17, 19, 20 here. After that small working we are getting this. I told you that after 21 and 14, 21 is greater than 14, hence it will, the Ath index will be 0, 1, 2, 3, 4th index, and it will break. We have to break 2 loops, and the resultant X that will be found will be 14, 15, 16, 18, 17, 19, 21, okay. And the sorted list will be this, but this and this list are not similar, hence we have to print it can't be easily correctable, okay. And X not equal to S, we need to print not easily correctable, and if C is not equals to 0 and C is not equals to 1, we need to simply print it is not easily correctable. Okay, so first of all let's remove this, and I guess it should work. So if 1 second, it is printf. Okay, sorry, it should be print, not printf. Okay, we need to wait a second. Okay, we need to print this also, like print A. Okay, let's run this. So we are first of all, okay, we need to print first easily correctable and then print A. So let's run this. So as you can see, we are getting all the test cases passed. So hence I hope you got this question. So thank you.